Hi, W.A. Nehemiah from GMMB Academy. We're looking at AOC, Area of Concentration in Organic Chemistry. For those of us that will be writing UTME exam and JAMB exam, you want to read your organic chemistry, which is 1/3 of the whole of your textbook. And you should know that the questions that will come out from that aspect in UTME is usually 1/3 of the question. You expect about 7 to 10 questions from that organic chemistry. Now, the organic chemistry for UTME has the pattern or the area where their questions come from. Now, the questions come from, number one, the naming of organic compound. Naming of organic compound. Now, if you want to do organic chemistry, you want to write organic chemistry exam, you should be able to name organic compound from all the homologous series, whether they are alkene series, alkyne, alkanols, alkanoates, amine, a lot. Now, another one you should be able to do is the reactions. Now, in these reactions, you talk about the names of the reactions. The names of the reactions. The reaction name. Alright? So the next thing is to talk about the calculation. And under the calculation, we'll talk about the calculation of the empirical formula and the molecular formula. Alright, so this is the aspect where the questions will come out from in organic chemistry. We want to start up with number one to show you how the questions from there will look like. Now, the organic compound are grouped into different homologous series. When we talk about the homologous series, we're talking about the families of this organic compound. There could be the families of the single bond alkane, double bond alkyne, triple bond alkyne, and then alkanols, alkanone, and the rest, a lot of them. But let's just talk about the alkane. Let's talk about the alkene. Let's talk about the alkyne. Let's talk about the alkana. Maybe let's add to it alkanol. Alright? Okay. Now, if you are given a structure, maybe this structure, CH3, 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 and you are asked to name this structure. Well, this family is a single bond alkane. It comes from this family of alkane, which is a single bond. To name this structure, you need to give the substituent the smallest number. Alright? This is not a class on naming. We have a class on naming of organic compound. You can check out for that if you will. So we have this substituent, we have this substituent. Alright? So these are the two substituents. We need to give the substituent the smallest name, the smallest number. So we are counting now 1, 2, 3, 4. The substituent falls on carbon atom 2. So this is 2, 2, di. The substituent name is methyl, di, methyl. Then what is the longest chain? The longest chain is 1, 2, 3, 4. Butane. Alright, let's give you another structure. Let's say we have CH3, 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 CH, CH3, CH2, CH3. Now, if you are given this compound and then you are asked to name, what will you do? Now, look at the functional group. The functional group of this compound is actually from the double bond alkane. So if it's from the double bond alkane, the naming of this compound, we have to respect this functional group. So I have to count, if I count 1, 2, 3, I'm respecting this guy. 1, 2, 3. It's still going to form on carbon atom 3. I mean the functional group. Now, but we have a substituent here. We're going to now arrange it in the form that we're going to give the substituent the smallest number. You're going to find in your option, I'm going to give you two options. They're going to give you maybe option A and option B. Alright? Now option A, they will name it in the wrong way. If you count from here, 1, 1, some people even make a mistake to count 1, 2, 3, 4. This is not the longest chain. The longest chain in this structure is this. This is the longest chain. Okay? Now, if you have gotten the longest chain, you will now find the functional group and give it the least number in naming. But we have a substituent, okay? So I have to respect this substituent. Let me give you the right name first. So I have to respect this substituent, which is two of them, methyl and methyl. So I will count from here. 1, 2, 3, 4, 5, 6. All right? The substituent falls on carbon atom 2. It will be 2, 2, dimethyl. What's the longest chain? 1, 2, 3, 4, 5, 6. So it will be hes. You see that? Hes. And then 1, 2, 3. The functional group is on 3. So hes 3. E is the end name for the alkane. Now, in your exam, you might find options. They will give you this. They will rename like this. 1, 2, 3, 4, 5, 6. They can give you 6, 6 dimethyl hes 3N. This is wrong. This guy is not the answer. The answer is this guy. So as we can give the substituent the least number and also respect the functional group. Let's say we have another structure. Another structure now. Let's say we have the combination of alkane and alkyne. Something like this. Okay? Something like this. This has two functional groups. We have the alkyne. We have the alkane. Now, this guy needs to lose 2 hydrogen atoms to form alkane. One hydrogen atom here, one hydrogen atom here to form the alkane, double bond. 2 hydrogen atom here, 2 hydrogen atom here to form the alkyne, triple bond. So what will be the name of this thing? We have to start counting from here. 1, 2, 3, 4. So this is boot. Okay? We have that 1, 2, 3, 4. 1, 2, 3. Boot. 3. 1. I. You see that? Boot. 1, 2, 3. This is carbon atom 3. So it is boot. 3 in for the alkane. Then 1 I for the alkyne. You see that? That's how to name that. Now let's give you maybe the last one for now. This is not a class on naming. We're just trying to show you how the questions will come from, or how the question will look like in organic chemistry. Let's say we have CH3. We have the CH2. We have the CH3, H, and then we have CHO. Now, what is the name of this compound? The name of this compound is 1, 2, 3, 4. Why? To give this functional group, which is the alkanal functional group, RCHO. Alkanol is RCO. Actually, we have a video where we treat all these things as a topic. All right? So you can check out for that video if you have time. So now let's check the name of this compound. The name of this compound will now be 2-methyl. Methyl, this is the functional group methyl. 1, 2, 3, 4. 2-methyl butanal. Butanal because Na is the end name for the alkanal functional group. So what I'm trying to say is that organic chemistry, we want to test your knowledge on the naming of organic compound. Alright? Especially when you have compound where we have 2 functional groups. Take note of that. Alright? Questions on that might be popping up for you. So let's go to the next thing. The next thing is the reactions that occurs in organic chemistry. The reactions that occurs in organic chemistry. Now take note of what I'm going to say here now, because it's very, very important. So we're going to the reactions. Now, first of all, you need to know the name of this reaction. We have dehalogenation reaction. We have a decarboxylation reaction. We have oxidation reaction. We have reduction reaction. We have esterification reaction. We have a fermentation reaction. We have a lot of reaction in organic chemistry. So when you are studying your organic chemistry, take note of first the reactant, second the product, thirdly the reagent, and fourthly the name of the reaction. Now I want to pick up just a family of alkane and notice the reactions that occurs in this family of alkane. Now to produce an alkane, just watch. To produce an alkane, follow me. To produce an alkane, we can produce an alkane from dehalogenation of halogenoalkane. From dehalogenation of halogenoalkane. Okay? Now an example of halogenoalkane is CH3, CH2, CH2I. This is called iodopropane. Iodopropane. Why is it iodopropane? Because of the iodine. Iodopropane. And halogenoalkane is the alkane that contains the halogen group, that has the halogen elements, whether it is chlorine, whether it is bromine, whether it is iodine or fluorine. Alright? But the most that is used for in the halogenation of halogenoalkane is the iodoalkane, like the iodopropane. Now, there is a reagent that will be needed for this reaction. Now, if you are talking about reactions in organic chemistry, the first thing to talk about, maybe we have A plus B is going to give me AB. All right? This side is known as the reagent. The reactant. The reacting chemical compound. Molecules or compound, yeah? Molecules, yeah. Now, because it's an organic chemistry. Now, this side is known as the product. All right? The reactant and the product. You must be able to know the reactant and also the product. Now, you should also be able to know the reagent that is involved or that promulgates or propagates the reaction. Now, the reagent that propagates or promulgates this reaction is known as the magnesium amalgam. Magnesium amalgam. Magnesium amalgam is magnesium in mercury. Magnesium amalgam and ethanol. Now, this will give you CH3, CH2, CH3. Have you seen that now? Now, what your chemistry question will look like is this. They might take away this, okay, and ask you, what is the answer to X? You get what I'm saying now? What is the answer to X? The answer to X is, what should be here is magnesium amalgam and C2H5OH. So this is how the question will look like. Either they ask you to find the reactant, one of the reactants, or the both reactant, or they ask you for the product, or they ask you for the reagent that promulgates the reaction. Now, let me give you another example. Let's say the production of alkane, let's start with alkane, production of alkane from alkane. We want to produce alkane from alkane. Now, this guy is the reactant, all right? The reactant, this is an 18 acting or combining with two hydrogen atoms to produce C2, sorry for my pen, C2H6. Now, what is the reagent that promulgates this reaction? The reagent that promulgates this reaction is nickel, and then at 10 atm and at about 25 degrees Celsius. So where the JAMB question will come from, I'm trying to explain to you, is that the question might ask you, what is the product? What is the reagent? Or what is the reactant? I hope you're getting what I'm saying. So that is how the questions will look like. Now let me give you another one. Let's say we have the normal one, the one they do ask on esterification reaction. Under the esterification reaction, there is the addition of arcanol. The addition of arcanol plus arcanoic. And then it's going to give me arcanoate and water. In fact, there's a question they ask you. The addition of arcanol to arcanoic acid is known as what? Esterification reaction. The reverse reaction of esterification reaction is known as what? Hydrolysis reaction. So when you are studying organic chemistry, take note of the reactions that is there. Take note the naming. You should know how to name organic compound, because you cannot study what you don't know. You have to know the name first, the name of the compound according to the homologous series or according to their families. Then you will now talk about the reactions or the features that occurs in that homologous series. And then in this setting, where you have a esterification reaction, let me give you an example. C2H5, which is an ethanol, CH3, COO, which is an ethanoic. It will give me CH3, COO, C2H5 plus H2O. Now, this name of this compound is called an arcanoate. So this is an ethyl ethanoate. So this is an ethyl ethanoate. But what is the reagent that promulgates or that propagates that propagate the reaction and make for the formation of arcanoate? What's the reagent? I'm waiting for you. H2SO4. I hope I'm able to pass this across to you. When you are studying, take note of the reactant, take note of the reagent, take note of the product. Are you with me? I hope you have gotten it. Now, in your JAMB question, they might take away this. And they will ask you to supply this in the answer, in your options. Okay, they will now put option A, CH3, COOH. Option B, CH3, CH2, COOH. Now, do you know if you use, this is also an arcanoic acid, but if you use it in this instance, you will not have a balanced chemical equation. So this is the right one to use. Alright? So these are what you should pay attention to. Let me slot it in back so that you can see that the equation will be balanced. COOH. Now forgive my pen. Alright? It will be better some other time. Alright, now check. We have CH3, CH3. We have COO, COO. We have CH25, CH25. We have one oxygen, we have one oxygen. We have how many hydrogen here? Alright, let's check it again. We have CH3, CH3, COO, COO, CH25, CH25. We have one hydrogen here, and one oxygen here. H2O. That's all. Now, let's go to the last one. The last one is calculations in organic chemistry. Now, the calculations that you'll be expected to look at is the empirical formula and the molecular formula, and which I will do a quick example for you. Let me divide the board. I have to do a very, very quick example. Yeah, I got this one. A quick example. So let's say we have a carbon, we have hydrogen, where we have oxygen. Alright? And then let's say carbon is 62.07, hydrogen is 10.34, and then oxygen is X. And then they say that the mass of this organic compound, let's say the molar mass, or the mass of the organic compound, not the molar mass now, the mass of the organic compound is 58. Okay? And then you are told to find the empirical formula and the molecular formula. Now, from this setting, let me put the mass up there so that it will not distract me. The mass of this compound is 58. I'm trying to show you how the question will look like. Okay? In the normal question, they will ask you, Calculate the empirical formula and the molecular formula of organic compound CH2O or CHO. Alright, with the molar mass, with the mass of 58, and taking that the percentage of carbon is this, okay, percentage of hydrogen is this, percentage of oxygen is unknown. Alright, let me give you the question. The question will look like this. Calculate the empirical formula and the molecular formula of organic compound with the mass 58, that's it on the board, having a percentage, having a carbon percentage, this, having hydrogen percentage, this, and oxygen percentage is unknown. What are we finding? We are finding the empirical formula and the molecular formula. The first thing is to find the percentage of oxygen. Now, you need to know that 62.07 plus 10.34 plus X should be equals to 100. Alright? Now, let's do the maths. What we're going to have now is, I need my calculator on, 62.07 plus 10.34. That is going to give me 73, okay, 73.04. 73.04 plus X is equals to 100. So X is equals to 100 minus 73.04. And let's do the math. 100 minus 100 minus 73.04. So what's that giving me? That's giving me about 20. Let me do it again. 62.07 plus 10.34. 72. Okay, I made a mistake here. 72.41. So this is 72.41. So 72.41. 100 minus 72.41. Let's do it now. 100 minus 72.41. So that should be giving me around 27.60. That should be giving, I'm going to remove this X now. I'm getting 27.60 approximately. So I'm putting 27.60 here. Alright, that is the percentage of oxygen. If I've gotten that, I can now solve. Alright, so let's solve now. Carbon is 12, so I'm dividing by 12. Hydrogen is 1, dividing by 1. Oxygen is 16, I'm dividing by 16. This guy will become 10.34. Actually, let's divide this one. We're dividing 62.07 divided by 12. That will give me about 5.1725. 5.1725. Alright? Now let's divide this. 27.60 divide by 16. That should give me 1.725. 1.725. Alright, so we are going to divide it. We are going to divide these parameters by the smallest ratio, by the smallest number ratio, which is this. Divide by 1.725. Divide by 1.725. Divide by 1.725. Let's see what we're going to have. So what we're going to have is 5.1725 divided by 1.725. What's that going to give me? That's going to give me 2.9, approximately 3. So carbon is 3, hydrogen is what? Okay, approximately 3. Hydrogen is 10.34 divided by 1.725. Alright, what's that going to give me? That's going to give me approximately 6. So hydrogen is 6. Oxygen is 1. So this is the empirical formula, CH3H6O. So this is called the empirical formula. So let's go for the molecular formula. The molecular formula will now become C3H6O, and then oxygen is 1. Number of the mole, when I mean this N means the number of this guy that is here. It could be any number, we don't know. So we are now is equals to 58. Alright? And that number is what we're actually looking for. We have that carbon is 3. 12 times by 3 plus 6. 6 times 1 is 6 plus 16. Everything is equals to 58. Now, 12 times 3. 12 times 3, that is 36. Remember, 36 plus 6 plus 16, and then I have n, everything is equals to 58. Now let's continue solving. 36 plus 6 over there plus 16, I have 58. So this is 58n, which I don't know, divide, is it 58? Yeah, 58. Divide by 58. Alright? So if I'm dividing by 58, okay, 58 and then 58, what I'm going to n is equals to 1, which actually means that the empirical formula and the molecular formula is the same thing. Alright? The empirical formula and the molecular formula is still C3H6O. It's still the same thing. The empirical formula and the molecular formula is the same thing. Now, this is just a formulated question, okay? So if you have a standard JAMB question, you will not have the same empirical formula and molecular formula. So having said that, I want to go back to what I did to make sure we did the right thing, alright? Alright? That's the right thing. That's the right thing. Correct. Complete. Correct. So this is what we have. Now, in summary, your question will come from naming, reaction, check note of the reactant, reagent, and product. Alright? The calculation, empirical, and molecular formula. So this is what we've got for you in this video. Thank you very much for